Our class will look at the probability distribution, which is the normal probability distribution. Now, under probability, we're going to look at three key distributions of key constant to your course. There's what we call the normal distribution. There's what we call the binomial distribution. And there's also what we call the discrete random distribution. So these are the distributions that we'll dominate on. So the normal distribution has the following characteristics that you need to take note of. Number one, as you can see from this shape, the normal distribution is bell-shaped. It is asymmetrical. It means the left quadrant is equal to the right quadrant. They mirror each other. Okay, so this means that here we have 0.5 and here we have 0.5. So the total area under the graph should always be equal to 1. Then at this point here, our mean, our mode, and our median are the same. They're equal to 0 if you standardize them. Mean is equal to the mode, is equal to the median. Then these tails don't touch, specifically the base, they don't really touch down there. So it's important to know the characteristics of this distribution because some of the exam questions just ask you to explain the assumptions under which it lies. Number one, it is bell-shaped. Number two, it's asymmetric. Number three, the mode, the median, and the mean are the same value. Number four, the area under the graph is equal to 1. So let me make use of logic here. If this is 50% and that is 50%, when you add them together, we're going to get what? 1. So this gives us what we call a continuous distribution. So if we're dealing with normal distribution and you are dealing with percentages, these percentages are called the probabilities. So the readings that we're going to look at for now will start from here up until the end. So the figures, when standardized, the middle is where the mean is when you standardize it. This is as good as 0. The biggest number here is about 3.9 negative. And here about 3.9 positive. So if you have a value like 1, so this value 1 here means the area from this point to this point is giving you the probability. So just to start with, the probability at 0 here obviously should give you 50% because this is where the middle is. So the figures going on the positive side of 0, if you're using a cumulative table, will give you probabilities that are more than 50%. So I need you to acquaint yourself with the two types of tables that I am going to take you through. There's what we call the cumulative statistical table and the non-cumulative statistical table. So for your class, I'll take you through what is called the cumulative normal distribution table. So as you can see, it's showing you the readings that are starting from this side up to that side. So we need to learn how to read these tables. As you can see here, this is our normal cumulative distribution table. So it's starting from here to here. So let's look at how to read the basic table. For instance, the reading at 1.0. So 1.0, as you can see here, 1 under 0.00, it's giving you 0.8413. 0.8413. So what does that mean? 0.8413. It means the reading from here to 1 there is about 0.8413. So this means that this is about 84.13%, 84%, which makes sense. If you're going to read the reading from here up to 0, it should be 50%. Let's see from the table if that's true. At 0, it's giving you 0.5, so meaning this is 50% here. So I want you to digest this table. You will not be asked to memorize. Of course, for me, I've been looking at the table, so I may know some of the values prominently. So now, if from here to here is 0.8413, what therefore becomes the reading from here to here? Starting from this part here. From here to here, what is the reading going to be? So the reading from this midpoint, just remove the 0.5 because we know by default this is 50%. So meaning this kappa will therefore be 0.3413. Now, this is where the other table comes in because it's called a half table. So the half table itself starts from the middle. So if I'm going to show you how the half table is, at 1.0, it's just going to start from the middle. It's going to give you 0.3413. So it's one and the same thing, except that people sometimes get confused. All right, let me take you to another table because I want to settle this once and for all. The reading from 1.64. So when I'm going to, these are Z values. Let's check under 1.64. So how do I read 1.64? I get the first two numbers there under 1.6, then where it meets with 0.04. So let's check in the cumulative table. 1.64. So 1.64, using the cumulative table, you go under 1.6 and 0.04. So this one will give me 1.64 will be 0.9495. 0.9495. So this means that the reading from here up to there will be 0.9495. Can somebody guess? If I'm using the other half table, what do you think the reading will be from here to there? What are we in our mind going to do? What do you think the reading will be from here to there? Since we know that this is already 50%, what will be the reading? This will be 0. What? 4495. It is simply by subtracting a 0.5 there. So this is how the other table will be. It will give you this figure. It's the same thing. So now let's fortify on how to read the table, because this table that we're reading is like an X-ray in a doctor's hand. So only you people will be able to understand these tables here. So if I ask you to give me the reading of 1.47, who can help me find the reading for 1.47? So you go under 1.4 and 0.07 here, where they're meeting. What is the reading? 0.9292. So this is called the probability, and this is called the Z. So sometimes I would ask you to read from inside. The probability is 0.9292. What is our Z? We just add the two numbers, 1.4 and 0.07. This gives us 1.47. So reading the table is paramount firstly, before we go any further. All right, if you're using the other table, obviously, all the figures here are less by 50. So it would have given you 0.4292. Okay, that aside, can somebody give me the reading for 0.83? What is the reading for 0.83? If this is our Z, what is the probability for 0.83? Yes, Sally. 0.83, what is the reading?
Now, the reading for 0.83 is 0.7967.
Yes, 0.7967. Okay, do you agree with him?
Yes.
All right. Now, if I were to ask you to give me the Z for this probability, even if I say 0.7966, you pick the closest possible. If there was no 66, this one will still qualify as 7967, so Z would still be 0.83. So, with that being said, help me find Z probability 0.8900. 0.8900. Okay, inside and help me find the Z reading to interpret that. 0.8900. So look for it inside. Find
Is it 0.89 or 0.98?
0.98.
Yes.
0.9800.
Two 2.06.
2.06 or 2.05, which one is closest?
5 is closer.
Yes, 2.05. So when you go inside there, 9800, so 2.0. So the two numbers that you are going to debate on, this one and that one. This one is more by 3, this one is less by what? By 2. So our Z here is 2.05. Okay. So just the ladies only. What is the reading for 2? For the Z2? What is the probability for Z2? And what is the Z for 0.9500? Quickly. Ladies only. 2.0 and 0.9500. What is the Z reading for that?
0.9772.
0.9772, correct? Under 2.0, where it means 0. So this one is just giving you 0.9772. So this simply means that if you're looking at the normal distribution table, the bell-shaped under 2.0, this means that our reading here will simply mean this is 0.9772. This is about 97.72%, which makes sense. So in actual sense, this other part here is 50%, which is obvious. and this other part is 47%, which is if you're going to split them, because the other table will only show you this figure here. It doesn't show the 50%. All right. So I'm breaking down this lesson. By the time I'm done with explaining these small dollies, you'd have understood the gist of it. So with this data that I've given you, if the researcher was asking you to find the probability that Z is greater than 2. So greater means what? The right side. So Z is greater than 2. We look for where the 2 is. The 2 is where? Here, in terms of Z. You put your divider. Greater means shade to the right. We're looking for this area here. But we know that from here up to here, it's about what? 0.9772. It's about 97%. The only way we can get this shaded area is by subtracting 1 minus 0.9772 logically to find the remainder there. Are we together? So in this case, we're going to subtract 1 minus that. So 1 minus 0.9772. So we're going to get 0.0228. The question can be flipped. They ask you find the probability that Z is less than 2. So Z is less than 2, same thing. The procedure is illustrate, standardize, and shade. The 2 is here. Then you're asked to shade less. When you're using this sign less, we're shading to the left side. So this left side can show you that the shading is a big shading, and all big shadings are more than what? More than 50%. So in this case, it's just a direct answer, because from here to here is about 97%. So don't subtract from 1. You get the answer directly as it is. So now, I don't want you to get confused at the moment. I want to take my time and I'll simplify using my own small formulas. I call this ISA. Illustrate, shade, standardize, and apply. So I've taught you how to read from the table. So we're going to use the same principles that I've just been talking about here. So if you're asked to find the probability of Z is greater than 1.67, and the probability of Z is greater than negative 1.33. So the first thing we need to learn is how to read the tables. How do we find 1.67 to start with? The Z for 1.67, we go into the table, we check under 1.6, then under 0.07. 1.6, then 0.07, we go down there. It gives us 95.25. 95.25. So reading that one, 95.25. I hope that is clear. We're not doing anything yet. We're just still recapitulating on how to read the Z. In this case, just ignore the signs for now when you're reading. So the gents, help me find the reading for 1.33. What is the reading for 1.33? The gents? You go under 1.3, where it meets what? The 3. So it's 1.3 and the 3. What is the reading? 9082. Are we agreeable?
Yes.
9082. So these are just mere readings. Now let's go through this process, which is called ISA. We illustrate. So for part A, we're going to do what? Illustrate. But let's look at the application. The application has 4 parts. Number 1, greater means what? Shade right. Okay. Less means what? Shade left. Okay. Then the shading can either be big or the shading can either be small. If it's big, just redirect as it is. If it's small, what do? We subtract from 1. So these are the only application rules that I'll give you for now. So I'm going to now look at this guy here, part A, and this is part B. So Z is greater than 1.67. So I'll go here, my 0 is there. Then 1.67 is there. It's a positive, so I'm putting it on the right side. Greater, what does greater mean? I'll shade to the right. So I'm going to shade this side here. Okay. Then application, like I not standardize because we're given in terms of Z. Unless it was in terms of X, we would have now calculated our own Z. But this case, we're already given the Z. So illustrate, we have illustrated. Shade, we have shaded. Standardize, it's already in the standard form. Apply. So this shading that we have here, is it a big shading or it's a small shading? So you can check. This is a small shading. How do we know it's a big shading? Big shadings can only come in 4 ways, in 2 ways. Number 1, you can have the following big shadings. If they say less than and shade left. This is shade left. And what? Less than. This is a big shading. You can also have a big shading as long as it's crossing the middle line. This is a big shading. So these two are called big shadings. This is big, literally. This is big. We can also have small shadings when we are we have pictures which look like this. This one is greater to the right. This shading is small. This is also when we have this shading less to the left. These are small shadings. It's a small shading. It's not crossing the middle line. Even this one is small shading. Whenever it's a small shading, we subtract what? The probability from 1. When it's big shading, we just read the probability directly as it is. So this is a hint I'm giving you. All right. So when we go back here, it says greater than 1.67. All right. So we're looking at shading to the right. So is this shading big or it's small? It is small shading. So confidently subtract the reading of Z. We already found it as what? 95.25. So you subtract from 1. So what do we get when you subtract from 1? 1 minus 95.25, we're going to get 0.0475. This is a final probability, it's like a 4%. Okay. Suppose we go to part B. Part B simply says greater than 1.33 negative. So using the number line, we already know that negative 1.33 is on this side. The negative just shows you where you are, but never having a probability which is negative. And the sign is saying greater. Greater meaning we're shading to the right. So we shade until we shade no more to the right. But what does the shading tell us? Is this a small or a big shading? It's a big shading. So therefore, what are we going to do? We're going to read directly. So Z greater than negative 1.33. There's no need for subtracting because all the figures in the cumulative table of which your school usually uses, it's usually a direct reading. So we're just going to get it as it is. This is 90.82. All right. Are we moving together so far?
Yes.
Okay, now suppose we're given intervals between the same sides, whether they're positives or they're negatives. For instance, I ask you to find between Z, between Z is between what? Which number is smaller? 1.33 is smaller than 1.67. Right? So both of them are positives. So you need to illustrate them here. Okay. Step 1, illustrate. So we have 1.33 and 1.67. So this is 0 here. Then you shade in between these two intervals. It's easier when they're on one side because it is easy. If it's the same side, just subtract the bigger number and a smaller probability number. Don't subtract the figures, but their probabilities. We know 1.67 when we read it, it was what? 0.9525. So this is the figure that we had here, 9525. Then 133, it is 9082. So meaning the reading here is 9082. So this logically means from here to here is 95%, from here to here is 90%. So to find the interval between these two, just subtract them. All right, so this would be 95% minus 90%. So the difference between the two is our interval. So we're going to subtract 9082 minus, okay, it's supposed to be 9525 minus 9082. This will give us 0.443. So it's about 4%. This is the difference here. All right, about 4%. So this is the toughest topic in the whole syllabus. If you understand it, then it simply means that the rest of it is going to be easier. So suppose we had negatives here, negative 1.67 and negative. As long as they're on one side, the principle of mathematics is the same. Just subtract the bigger number probability from the smaller probability because the interval is the same. So we're going to simply subtract what we've done there. 1.67, it is here. 1.33, it is there. So simply subtract 0.9525 minus 9082. So the difference between these two, we get 0.443. This is when we're dealing with on the same quadrant. All right. It becomes a problem when they're on different sides. One is negative and one is positive. So they're asking you to find the interval between negative 1.33 and Z, which is between 1.67. So this simply means that you're on one side of the negative side and one side of the positive side, and the 0 is sandwiched. The mean is in the middle. So this is what we call case 3. This case, because most of you are very lousy with mathematics, I'll give you a simpler way than the complicated way. Just add them and subtract 1. So the probability for 1.33 is 9082. The probability of 1.67 is what? 9525. So just add the 2 and subtract the 1. So just add this probability plus that probability minus a 1. That's all. Then you stop thinking.
Just a second on that.
Uh-huh.
On the probability for negative 1.33, it's not what you have indicated there to say 0.9082. According to the table, it's showing 0.09176.
Okay, I'll get to that. We're only considering at the moment the positive table. You're right. And also a little bit ahead. So I've concentrated on one type of a table. There are tables that have negatives. In that case, if you're dealing with tables that are negative, they'll give you probabilities that are exact. Now, in this case that I'm trying to illustrate here, you can forget about the negative table because this rule only works on the assumption that we're just using one type of a table. What you're telling me is that the probability from here to here, you're right, is if you're going to use a negative table to the probability from here to here is a difference from 1 here. So 1 minus that one, it will be 1 minus 0.9082 to give you 0.0918. Okay, is that correct?
Yes, it is.
Yes. So that is a reading from your table because it's coming from this origin. Then from here to there, it's already okay as it is 0.9525. So if you're reading it as exact as they are appearing with their signs, it becomes even easier for you to just subtract the bigger number here, this one minus that one. All right, if you're reading the negative as it is, just subtract 0.9525 minus it will give you 86%. So the difference will be between these two will be 0.8607. That is if you have the negative table. However, if you don't have the negative table, I summarized there because this one is already subtracting from one of them. This multiplication is already, this subtraction is already done by this negative one. So you simply add this plus that minus 1, it will still give you the same answer, 0.8607. So you can choose either of the two options. I'm glad you brought it at this point. Are we together?
Yes, we are. Though, I'm a bit behind. I'm a bit behind on the scenario 2, and the scenario 3. Were there differences in the values? I think I missed out a bit.
Okay, so let's do one together, then I'll take you through a case of x's, then we go together. So let's do all the cases, case 1, case 2, case 3. So suppose you're given the z of 1, the z of 2, just these figures. Can you help me read what's the probability of the z1, 1.0? What is the reading? 1.0, what is the reading?
Uh, 0.8413.
Do we all agree?
Yes, we do.
0.8413, correct? Then what is the z reading for 2?
Now 0.978.
9772.
8.
You read it as it is in the four figures. 0.9772. Are we together?
Yes.
All right. Don't round off. We're dealing with 4 figures here. 0.9772. Now with this data only, I want you to get the principle. Don't go very far. I'll start with who would help us find the z greater than 2. From the ladies, from the gents, who will help us find the probability of z less than -1. Quickly, let's use Isa. Step 1, what are we doing?
In step 1, we are illustrating
Okay. Illustrate
the graph.
there. Where's the 2? On the left or the right of 0?
It's on the right of 0.
So 0.
We put the 2 there and our divider here. Where are we going to shed?
On
Greater
your,
than the right.
The
on
right?
your right, yeah.
Why right?
What you
It's
say?
greater than 2.
Because of the sign, correct? Then what does the shading tell you? Is it a small shading or a big shading?
It's a small shading.
A small shading.
When the shading is small, what do we do? SS, small, subtract. Aye.
Subtract.
Yes. So let's look at the stages. Have we illustrated? Yes. Have we shaded? Yes. Is the Z already standardized? Yes. What is our application? There are 2 things. Identify whether it's big or small. So it's small. Therefore, what does it mean? If it's small, we're going to subtract from what? From 1, right? So what is the reading for 2? 0 point what? 9772. Are we together? Then we subtract.
Yes.
Are we together?
Yes, we are.
Okay, so the reading here is 0228. That is a done deal. Let's go to this other one. Illustrate. Where is -1 based on the 0 on the left, on the right of 0?
On the left.
Because the negative, right? And we put our divider. Where are we going to shade, the left or the right?
You said Z is it less than or
Less than.
Less than.
less than?
So
So meaning
on
it's
the
on
left
the
side.
Where?
Left side.
Left, correct. The shading is small, it's big.
Small.
small.
So, are we going to redirect or we're going to subtract?
Subtract.
Also going to subtract from 1. What was the reading for Z? For 1?
0.8413.
Correct. Now, if you're using the table directly, because all the readings are starting from this, so I need you to get me clearly. I'm working on the assumption that you're just using one side of the table to understand the concept. But if you go to the table directly on -1, just give you the direct figure as long as it's touching the O where it's starting from. When you read from inside the table directly, it will give you the difference we're going to get here, which is 8413. So we're going to get 1587. So this is the figure you're going to get. So if you're going to read with the negative table, just read directly because it's touching where it's starting from. But I want you to get the concept I'm getting here. The one we're getting is what? 8413, subtract from 1 to get this figure. All right. Now suppose we were asked to say greater than -1. The same figures, but the narrative would change. So our 0 is there, our -1 is there. We put our divider there. Greater, we're going to look at this side. All right. And this side is what? Big. So whenever it's big, we just read directly. The reading for 1 was what? 0.8413. And this makes sense that this cannot be 15%. It's 84%. It's a bigger one. So this is qualified. So these ones, I'm sure you don't have a problem. Where we have a problem is the intervals. Suppose we have an interval between 1 and 2. Both of them are positives. This is the easiest case because they are all on one quadrant. So 1 and 2, I said if they're all on one quadrant, we just simply subtract the bigger one from the smaller one. So this means the bigger one is what? the 2. The reading for the 2 is 0.9772. And the smaller one, the reading for 1 is what? 8413. Subtract them. So in this case, when you subtract them, what you get is the difference, which is 1359. This would also applied if you were given to find the interval between what? -1 and -2. So the illustration will just be the one that will look a little bit different, but the concept will be the same, that -2 and -1 are all on one side. As long as they're all on one side, we know that the reading from here to here is 97%. From here to here is 84%. And subtract them. So the only case where I think my sister had a problem was on account where there are two different signs. So when there are two different signs, just understand that we're using case 3. Our 0 is there, we have -1, and here we have +2. This is crossing the boundaries. Our figure here, the simplified way that I just told you was, let's add them and subtract 1. So we know that the +2 is 9772. When you add these two and subtract 1, you're going to get the final answer. Without hesitation, this is what I've just been explaining. I don't know whether I was a bit fast on that one, but final answer will give you 0.8185. Now, examiner may not bring it as easy as it comes. He'll now allow you to standardize the figures. This is where we learn the standardization rule, which is given by Z is equal to x minus mean over standard deviation. So you'll be given, for instance, that maybe your mean is 10, standard deviation is 3. Part 1, find the probability that x is greater than what? 16. So we can now use ISA. ISA says, step 1, illustrate. All right, our mean, we know it is always at what? At 0. But this time we've been given a mean of 10. So 10 is equivalent to 0. Then 16 is on the right side. We're given 16 in terms of what? X. But what is the value of 16 in terms of Z? We can calculate our Z by using the standard formula. So standard formula says x minus mu over standard deviation. So our x is 16, sorry, and our mean is 10 divided by 3. So here we're going to have 6 over 3. So meaning our Z is equal to 2. Well, this simply means that this 16, when you standardize it, is as good as 2. And now it says, illustrate, shade. We're going to shade to the right because this is greater. Standardize means how can we interpret this 16 in terms of Z? It's as good as 2. Then apply. What is application? Our application is that this is a small shading. So the same rules we're talking about, we're going to subtract. So you can simply say Z greater than 2 will simply be 1 minus 0.9772. I'm sure you've memorized the 2 already, where it's coming from. When you read this 2, it is 0.9772. All right. So when you subtract it from 1, that is 0.0228. I'm intelligently using figures that are giving us a Z values that we are already familiar with, because we read what the reading of the standard value of what 2 is. So the 2 was coming to 0.9772. Let me come up with an irregular figure. Suppose you're being asked to find the value of Z less than 15. Here you need to calculate. So we illustrate our 10 is here in the mid because that's the mean we're using throughout. Our 15, we need to standardize it. So we know that x minus the mean over standard deviation will be the value of our z. So 15 minus 10 is 5. 5 divided by 3, you're going to get 1.666666. You need to round off to the nearest 2 decimal places for you to read the z values. Z values must always be in 2 decimal places. So 1.67. So remember 1.67, when you read it from inside the table, it is giving us what? 95.25. I've mastered this because the figures we work around with. But just for the sake of somebody who missed on reading it, 1.6 is here, 7 there, 95.25. So this is where the figure is coming from. So 1.67. So using our ISA, we're only on what? Step 3. These can be used interchangeably. We're still in step 3. You standardize before shading. Shading is not a problem. Less than 15. We're going to shade to the left. This part here, we are shading until we shade no more. I don't know why people who end here. Why can you end here? You shade until you cannot shade anymore. Then this shading is big. Application says if it's big, therefore we read it directly. So there'll be no need of subtracting this one from what? From 1. Simply the bigger percentage there. All right? Simply the bigger percentage there. Sometimes they'll give you intervals. It's the same thing. Between 7, x is between 15. What is the probability between these two? The first thing is you need to standardize these figures there. All right? You know that our 10 is in the middle there, but use your number line. You cannot put 7 in front of 10. 7 is obviously here. And you cannot put 15 behind 10. 15 somewhere there. What we need to know is the z value for the 15 and the z value for the 7. You put your dividers there. Of course, this interval, we're looking at this what? These two figures there. So Z1 and Z2. So 15, we already calculated the 15. 15 minus 10 divided by the standard deviation of 3. What are we getting? We got 1.67. So that is what we're just from calculating. 1.67. And we know that 1.67, the reading we just got was 0.9525. Then we standardize this 7. 7 minus 10 is -3. -3 divided by 3, we're getting -1. And we know all figures on the left side are negatives in terms of z. And 1 should be in your DNA. These figures will be recurring most often. 8413. So let's check it out if that is true. The reading at 1. So when you go to 1, the reading is 8413 when you standardize it. These standard figures are like converting an exchange rate of a kwacha to a dollar. We're only using dollars in here to read because you cannot find a 7 in there. The highest number is a 3. So that's why we standardize them. So can somebody remind us if they're on opposite sides, or how do we get the interval in between?
You add
You add the 2 and subtract 1.
Excellent. You add the 2 and subtract from 1. So in this case, we're going to have 8413 plus 9525. Then you subtract a 1. So this will give us the interval, which is 0.7938. Now, the examiner sometimes will be tricky to say, find the percentage which is greater than 2%. Find the value of Z, the percentage is more than 2%, with the same parameters. Our mean is 10, our standard deviation is what? Is 3. So we are being asked to find the value of Z, for which we are greater by 2%. So we go here in the table. We know the mean is what? At 10. Standard deviation is already at what? 3. All right, then we're told greater. Greater is on the right side, so we can't put it this side. So we just cut a percentage here. The 2%, we just remove it here. If it was less than 2%, we'd have cut it from there. So we cut off a 2% from the 100%. What do we remain with? 98%. Now I taught you that whenever you're given a probability, you're being tempted to read from inside the table. So we went to check for 98% inside the table. I'm sure it was people who
Okay.
so Chipo read it for us and gave us 98% was 0. What? 205. Remember this, eh?
Yes.
So when you go now here, this is equivalent to a Z of what? 2.05. So we're going to ask, we're being asked to find the value of X. So we know that Z is equal to X minus mean over standard deviation. So our Z is 2.05. Our X, we don't know. Our mean is 10, and our standard deviation is what? 3. So you cross multiply there. X minus 10, and this is 3 times 2.05. So in this case, to find the value of X, we're going to do what? We're going to add the 10 plus 3 times 2.05, just operations of math. You can multiply them this side and subtract whatever you're comfortable with. But the principle is simply, you understand the concept here. So 3 times 2.05, then it's 7. And then when you add a 10, you're going to have 17.943. Okay. So sometimes, suppose they asked you, find the probability for which we are less by, find the value of X for which we are less by 28.1%. Okay. The mean is still 10. The standard deviation is still 3. Can somebody help me? Which side are we going to cut now? On the left or on the right side?
On the left.
On the left. So if cut off the what? 28.1. So what remains this side? 28.1 from 100. What is remaining? Or 1 minus 0.281. So we're going to get 0. What? 0.719. Since I just added 0 there. So you find the decimal of this one here. So we read from inside the table, 7190. So help me find the Z for this one. Go inside the table. Which one is close or exact to this one here? 7190. You find it is here exactly, right? So what is the reading there?
Now it's 0.58.
Excellent. 0.58. So this means this side, it is 0.58. Wait a minute. It is on the left side. Anything on the left side assumes a negative value. All right? So don't forget that. So we are interested in finding what? The value of what? X. So where there is Z now, we're going to put 0.58. Then the X value, we don't know. The mean, we know it's 10. The standard deviation, we know it's 3. So cross multiply, we're going to have 3. It is 0.58. Then here we're going to have what? 1 multiplied by everything there. So X minus what? 10. So when the 10 comes inside, it will add 10 plus 3, negative 0.58. Then value of X. Quickly go to your calculators. go to your calculators and identify the value of x. So it's an interesting topic, but you cannot guess. If you don't know, you don't know. All right, so these are the theorems that you needed to know. So this question carries more marks. In the exam, it doesn't shorter, carries about
11.74.
11 point what? 74, correct. No, it can't be 11, it should be less than 10. So this is a negative. So the negative, sorry, negative. This one just came to add. So it should be less than 10. So 10 plus 3 times negative 0.58.
Is it 7.54?
Yes, 7.54. Okay. Now let's go to the exam. Now you will laugh at how the exam came. It is very walkover now. So this is how normal distribution came. So we are told that the selling prices of various homes and community follows the normal distribution. The mean is what? The mean is 276. The standard deviation is what? At 2000. Calculate the probability that next house will sell for more than 206. For less than 220. 2 marks, 2 marks. So what are we given? Our mean is what? Just scrap out the zeros, 276. Our standard deviation is what? 32. But A, find the probability that it is more than. More than is just synonymous to what? Greater. So asking us to find greater than 206. All right. Then part B, less than 220. So Z is less than 220. All right. So what are we going to do? ISA. What does ISA say? Illustrate, standardize, shade, and apply. So if we're going to illustrate, it simply means that our mean, which is standardized as 0, is, in this case, our mean is what? 276. So what is going to be in the middle? 276. Then the value of x, part 1, greater than 206, when the mean is 32. 206. Where is the 206 going to be? Standard deviation is 32. Where is the 206 going to be? On the left or on the right side? It is here, the left side of the mean. All right. So greater than 206. X is greater than 206. Which side are we going to shade?
The right.
The right. Excellent. And what does the application tell you about the shading of the right?
If it's bigger, you leave it as it is.
Good. It's definitely bigger, so we leave it as it is. So when you standardize this one, you're obviously going to have a negative figure for this one because on the left side of that. So Z is therefore going to be what?
Just a quick one. Just a clarification. Why have we put 206 on the left and not on the right?
The number line. If this is 300, you can't put this on there. You use a number line. 206 comes before. The mistake people make, they are referring to 0. Don't refer to 0, refer to the mean, mu. So you can't put 206 after in terms of the number line. Good question, although I clarified it. Is that clear?
Yes.
All right. I'm not going to give the answers because this will be your homework. I'm just giving you an idea. So the figure you get here, you standardize it and you read it from the table. Then the probability that you get, you read it directly. All right. The next one, still 276 is here. Then standard deviation is 32,000. Then we're going to identify which figure they're asking us. Less than 220. So now you tell me, the one who asked the question, where are we going to put 220? On the right or on the left?
On the on the left.
On the left, good. Then we put our divider. Where are we going to shade? We're saying less than 220.
On the left.
On the left again, good. Is it right?
Yes, he is. The small shade.
Yeah, I'm a bit lost. Yeah. I
Where?
wanted to find out whether they say less than or greater than. We just have to follow the number line.
Yes. The signs only tell you which side you are shading. On the left side, on the right side. So less is always on the left side. So less, regardless, can come from two sides. Less can be from the left side to the left. Less can also be from the right side to the left, except that this less is small. This less is big. This less will subtract from 1. This less will redirect. You can have also two greater thans. The greater than that will come from the left side to the right here. And this one is big, read directly. And a greater than that will start from the right side itself and go to the right, which is small. For this big greater, we redirect. For this small greater, we subtract from 1. Is that clear?
Yes, it is just confusing.
Yeah, for math,
Sorry, Colin.
topics thrice.
Sorry, a question just for my own study. This one, the formulas and the way we are going about it is the same, except we are doing big, get it as it is,
Yes.
small, subtract from 1. What about the other ones where we had the 0.5? Does
Yes.
it apply here? That's a
No.
totally different.
5, you use the table, which is the half table that I was talking about.
Okay. All right.
So I'm trying to align my teaching to the table that your lecturer is using, which is cumulative. Of course, I'll teach you how to use a half table because that is what is in the notebook. But he brings the cumulative table. Interchangeably, I also want you to understand both tables, but this is what he often brings. So to avoid boggling your minds, you may better be placed to understand.
It's better I stick with this one. Okay, thanks.
All right. Okay, so thank you so much for your time. I will send this homework in the previous exam paper. I'll require, in fact, this question is there in the homework I sent last time. So I'll share this. You can try it on your own. Unless there are any questions.